Hello and welcome to this podcast on plate boundaries. In this short video, we will look at what makes the plates move, what direction they move, and what happens when they do move. Now, according to this diagram, there are many vocabulary words to be learned, and there's many arrows and directions that we have to pay attention to. So this is a time that we'll be taking a lot of notes and gluing down photos as needed. So get ready. We will begin by looking at the layers of the Earth. The layers of the Earth are broken into four main regions. We will begin by looking at the crust, which is divided into two main regions, known as the oceanic crust, which is very thin and is below the water, and the continental crust, which can get as high as 100 kilometers thick in some regions. Together, the crust will sit above the mantle. The mantle is the thickest layer, which is 2,800 kilometers. The mantle is broken into three regions. We've already heard about the asthenosphere, which is almost like a liquid plastic. It can flow. It is directly below the lithosphere. Now, the lithosphere contains the crust and an upper rigid part of the mantle. Together, they can be quite cold and brittle, and this lithosphere does sit and move above the asthenosphere. The other portions of the mantle below the asthenosphere is quite rigid. Now the core is broken into two regions. We've got the outer core with a thickness of 2,200 kilometers. It is very hot and it's liquid. Now the inner core is surprisingly solid. It's because of the great pressures that make it remain as a solid. Its thickness is 1,278 kilometers. Together, the outer core and the inner core are made up of iron, which is what makes the Earth magnetic. Now we will look at the Earth's vertical profile. We can see again the word lithosphere, which contains all of the crust and the upper portions of the solid mantle. Together, they move above the asthenosphere, which is like the plastic layer, or like toothpaste. Now, the core in green is made up of the outer core, which is a liquid layer, and it's the only liquid layer in the Earth, and the inner core, which is solid because of the pressures. Now, how do the plates move at all? Well, because we know that the Earth's layers are extremely hot below the crust, we then will look at a lava lamp. It's a very good analogy to show what happened when you heat up a material. This yellow material, when it does get heated, will expand and rise. And when it reaches the top, it runs out of heat, and then it contracts and begins to sink. Again, it reaches a certain temperature, and it expands and rises again, and it will continue to flow upwards and downwards as it creates a convection current. Now, this can be the same analogy used to explain what happens below the crust. The heat below also creates convection currents with the magma. As it rises, it pulls with it the crust, and it pulls it in an outward direction. We call that a slab pull. But when it cools down, it returns downwards, and with it, it pulls the slab of crust down again towards the magma, where it will return and melt down. This will drive the plates in two very distinct directions. Upwards will pull the slab of crust apart. When it comes downwards, it pulls the slab of crust inwards. We will now look at the three types of plate movements that occur above the mantle. We have divergent boundaries, convergent boundaries, and transform boundaries. Now, this is a good time to take note of all the photos that will need to be pasted for each one of them.